my two best holes. I mean, you have 7 hours. Oh, you're fine.
Hey,
MJ, how many Riley?
I only went to it once on the website.
that's where you go.
Once.
Bang.
And then
I'm
I
ready.
my face sheet, so when I don't think much.
Okay, so I told you the other day, at essence, algebra is about two things. It's about operations and it's about groups. Does anybody remember an operation that we use in mathematics? Addition, subtraction, multiplication, division, all these good things, right? And then we also have things that are called groups. And you might have, say, integers like 1, 2, 3, and 4. You might have, say, all real numbers, negative infinity to infinity. You might have algebraic expressions like x minus 5, okay? But today we're going to teach you a new operation. This is an operation that you do not know. And the operation is called composition. Excuse me, composition. And the thing about composition is you cannot do composition with numbers. Okay, so if you're like, what is composition? I can't explain it to you like I would addition or subtraction or something like that. Okay, because composition is used for different groups. And the group that it's used for is functions. So what we do is we literally take f and we compose it with g. Or we take g and we compose it with f. That does not mean multiply. It does not mean multiply.
Composing it.
Composing it. So what does composing mean? Well, sometime you were in 3rd grade, and if you would have seen this, square root of 64, you would have asked yourself, or the person who was teaching you said, what is that thing that you wrote over the 64, right? But after a while, you started to gain an understanding, and right now you don't even think about it, but you're saying to yourself, what do I multiply by itself to get 64? That's what that means, all right? So what does the circle mean? Here's what the circle means. F composed of g is defined as, we have g and we have function f. We start by taking x, and what we do is we plug it into function g. When we plug x into g, we get an output, which is g of x. Once we get the output of g of x, anybody know what we do with it?
Plug that into F.
We then plug that into f.
Good job, Keaton. Thanks.
And we get out f of g of x. So f of g of x is defined as f of g of x. These are synonymous. So if you have the circle in the middle, that means composition, which is what you have right on the end. Those mean the same things. So you can see I have problems written differently here. Sometimes it has the circle, sometimes it doesn't. They mean the same thing. You might see both of those, either one, pop up in that way on the ACT. So let's try a basic example. Problem number 1. It says f of g of 0. That means I take 0 and I plug it in for g. And I have 0 squared plus 2 times 0, which is 0. So now I take 0 and I plug it in for f. So this is f of g of 0 is the same as f of 0. I take that 0 and I plug it in for f, and I get 2 times 0, 0, minus 3 is negative 3.
Oh.
Okay. The next one, f composed of g of negative 2. I take negative 2 and I plug it in first for g. And I get negative 2 quantity squared plus 2 times negative 2. That produces for me 4 plus negative 4, which is 0. So when you plug negative 2 in for g, it produces 0. Now what do I do with that 0?
Plug it into f of x.
Yep, and we know what f of 0 is. We've already produced it. It is negative 3.
Nice.
I would like you to try letter B on your own and letter D on your own. Go ahead, try B and D. Kind of doing the most basic elements of composition right now.
Because you're plugging F, Z to F first.
Oh. Thank you.
You're welcome, bro.
Sometimes you need a guy named Keaton on your side. And he'll help you out.
Of course.
Check your work. I got 3 and I got 35.
What am I doing?
Ledger, can you please share with me what you got and for which one, top or bottom?
For B,
For B, what'd you get?
I got -3.
Okay,
I don't really know.
That's what I did.
so let's just talk it through. I take -2 and I plug it in for F. 2 times -2
He's
is,
on B, he's on B.
oh, this one, okay. So I took 0 and I plugged it in for F. 2 times 0 is 0.
Yep.
-3 is -3.
Yep.
So now I take that -3 and I plug it in for G.
Yeah.
So G of -3.
So,
-3 squared is 9. 2 times -3 is -6. So I got an answer of 3.
2 times. Oh, yeah.
Is that better?
Yeah, so it's 9 minus 6.
Yeah.
Okay.
Good? Okay. So one thing I want you to notice is this, that 3 plus 5 is the same as 5 plus 3. Everybody agree that you can move things around in addition and it retains the same value? But 3 minus 5 is not the same as 5 minus 3, is it? So addition and multiplication are commutative. You can move them back and forth. Division and subtraction are not. Look what happened here. We simply changed F and G. Did we come out with the same answers?
No.
We didn't. Here we just simply changed F and G and we did not come out with the same answers. So what do we know? Composition is not commutative. It is not commutative, okay? So don't just assume because you change the orders they're going to stay the same. What about letter E? What's different about this? Yeah, they're the same. So I'm going to write down 2x minus 3 and I'm going to write down 2x minus 3. I'll write it down both times. I take the 1 and I plug it in here and I get 2 times 1 is 2, minus 3 is -1. So now what I do is I take -1 and plug it back in for F again. And -1 times 2 is -2, minus 3 is -5. So I plug -1 into F 2 times. See if you can compute letter F on your own, G of 1. Try G of 1. Or some of you have already done it because you're super smart. When you're done, you can look up and glance and see where you're at. Very good.
I got that one.
Okay, so as I said, did you know how to do this before you came to class today?
No.
No. So for those of you who are juniors, this is the type of stuff that will come up on the ACT considerably. So seniors, you hadn't seen this yet, had you? So you guys were a little bit disadvantaged in that way. So juniors, you are, by the time you take the ACT, you will have seen everything possible that would be on the ACT. Okay, we take pride in trying to make sure that we get some really good ACT scores out of this class. So you should be ready to go. But when the ACT asks that question, that's not very tough, is it? You just have to know what you're doing. So that's something we'll retain for a while. We're gonna skip letter H and letter J, but what is different about letters G and I compared to the other ones?
It's not numbered.
Yeah, there's no number. And so this is, we are going to write a new rule for f of g of x. So I have f of x, I'm going to write it down so we can see it because it's way up there, is 2x minus 3. and g of x is equal to x squared plus 2x. So what I'm going to do is I'm going to take g of x and plug it in for f. So that means I take this, and instead of plugging a number in for x, I take this whole expression and plug it in for x. And when I do that, I get f of g of x is equal to 2 times the quantity, x squared plus 2x, minus 3. Now maybe this looks a little bit familiar when we did like our f of a plus h and stuff like that. There's a reason why we train you guys for that, because we want you to have success when you see this type of stuff as well. So on the test, I'll ask you to write it without parentheses. We get 2x squared plus 4x minus 3. That's your new composition function.
Sick.
And this is useful because in the next lesson tomorrow, you're going to do this a lot. We need to know how to do it. And then when you get to calculus, the calculus lesson today and yesterday and tomorrow is all about composition functions. So it's something we do use moving forward. Try letter I on your own. Letter I on your own.
No. Oh no.
4x minus 9?
Yeah.
We good? All right, great. Flip over to the other side. You should be able to handle the questions in a graphical nature as well.
Oh, okay.
So it says f plus g of 2, which is going to be f of 2 plus g of 2. So all I need to do is look at function f, which for me is in the blue. You guys don't have a color copy, sorry. And then g of 2, which is in the red. So I'm going to locate the number 2 for x. I'm going to look at the height of f, which is negative 2. And the height of g of 2, which is positive 2. So that result is 0. We're going to switch it. We're going to do g minus f of 0. So it's g of 0 minus f of 0. The height of g at 0 is 2. H of 0 is 0. And so I get 2.
Oh, I switched them around.
I'd like you to try the next two on your own. F of negative 1 times g of negative 1, and f of 0 divided by g of 0. Please try those two. See if you can come up with the correct answers.
Times g of negative 1?
Yep. I have 1 and 0. Then let's move on to the new part, which is let's compose them together. So notice it says f of g of 1. So I'm doing f of g of 1. And I'll do g of f of negative 2. I'll do the first one. You can do the second one. How do you think I start this first problem? What do I do first?
Plug in -1 into g.
I grab 1, okay, and I plug it into g. What is the height there?
3.
3. So then that becomes f of 3. So notice the output of 3 now turns into the input for f. So now I identify 3 as my input, and the output for f will be -1.
Okay.
see if you can do the next
So
one.
you got G1, right? So this is G. You go to 1 here, and then you find the height of G, which would be 3.
Wait. why is it-
Since the height of 3, that's where you plug, and then you
why it's
have
negative.
3.
Mhm.
Okay?
So,
So then
because
you
the
go
F
3,
function is the blue one.
x-axis.
So you see I get out 3, right?
Yeah.
But then I'm looking for the height of F, which is
That's how you
negative
get
1.
your answer.
G was positive, but I'm looking for F.
Oh, yeah, I got it.
Okay, better?
Yeah.
I've got 2. We good? Okay, again, it is all new, but it is not, it's not necessarily difficult. All right, now we're ready for the slightly more difficult part. We gotta talk about domain. Take out your calculators and move back 2 pages in your notes. So you see this section right here.
Give me the count.
Where are we at?
On the bottom, maybe flip it over.
Two back.
It's not charged. This one's counted. You check it out.
So is mine.
Where are we at?
Okay.
You guys,
I'll back up 2 pages in your notes.
You need to start charging your calcs.
I go home and
I bet MT charges his calc.
I think you're okay. I think you're okay.
Oh.
So if you do change your batteries, just one thing you might want to keep in mind
mine is just always.
is that you have 2 different batteries. So you have the AAAs on these, okay? And then you also have a backup battery. So it's not a bad idea if you, how long have you had the calculator?
Oh, wow.
Have you ever changed the batteries before?
No.
So I would say every 2 times you have to change your batteries, go ahead and replace that backup battery as well. And do it before you change those. Do you see what I'm saying? If you take out these batteries and the backup battery, then you'll lose anything that was stored on your calculator, for example, like the quadratic formula or things like that. So anyway, just something to keep mind of. So some of yours don't necessarily need backup batteries. And then my good friend Arai, she's going to sometime write her name on it. That way, if she loses it, we know who to give it back to, right? So that's the other thing to make sure. Miss Hanson downstairs has an engraver, and she could engrave your name on there if you want.
That's
It's
sick.
engraved on this one.
Yep.
Where?
There.
Yep.
Oh, that's right.
This
Where's?
is not mine, I buy.
Okay.
I rented it.
Okay, so do you remember when we talked about domain the past couple days, and we said when you look at function domain of addition or subtraction or division, we said it's the overlap. So we kind of looked at where these things overlap. We said, well, they overlap from 1 to 4, and we said that that's our domain. That's not the situation with composition, okay? So I only want to focus on this example right now, but what I want you to do is to talk to the person next to you and see, what do you think is the domain of the square root of x, and what do you think is the domain of x squared? Talk to the person next to you. What do you think of those 2 domains? Go. What do you
All
got?
real numbers are
X squared scattered. X is, there's nothing where we point X is. But then F says.
bracket.
It's gonna go point. It's a point to
Zero.
zero. Point You can't take the square root of it.
Found it. Did you bring it to lunch?
Attention students. Anybody who needs a picture retake, please report to the auxiliary gym now. This is the last call for picture retake.
Domain of the square root function is from 0 to infinity because you cannot take the square root of a Negative. And the domain of x squared, it's a polynomial, so the domain is all real numbers. But we do not simply look at the overlap, okay? We don't simply look at the overlap. What I want to do is I want you to look at the composition, and we're going to then identify the domain here. It says consider f of g of x. So I'm going to wait before I simplify it. I'm going to take g, which is x squared, and I'm going to drop it right in there. And I get the square root of x squared. Okay? All right? Now, what is the square root of x squared?
All real numbers.
X. Very good. Yep. Right? Now, Keaton, what is the domain of x? It is all real numbers, but you don't look at it after it's simplified. You look at it beforehand. So let's think of this together really quick. You're starting with the x squared, and then you're taking the square root. So what kind of numbers can you plug in for x squared?
All real numbers.
All real numbers. Okay? And when you square it, it becomes positive. Can you take the square root of all those positive numbers?
Yes.
Absolutely. Absolutely. So you are right that the domain here is going to be all real numbers. Now, here's what I think is just truly interesting about mathematics. Is that if you think of this in terms of it's being simplified, what does the graph of x look like? Y equals x.
Well, is it?
A line with a slope of 1 that passes through the origin. And we would think that it would want to look like that. But just think about what we just said. You square the values and they become positive. And when you take the square root of a positive, you only get
Positive.
So it would seem that even though the graph is x, it seems like you should only be able to get out positive numbers. So in your calculator, let's type that in. The square root of x squared. And then we're going to zoom 6.
Oh, it looks like the
What function does it look like?
absolute value.
Yeah, it turns out that the square root of x squared is the absolute value function as well. They're right on top of each other. In fact, if I went back into y equals and I typed in catalog, whoop, sorry about that, go back. Second catalog, and I grab the absolute value of x, and I grab that, it's going to go right over the last one. They're identical. And so you don't get the perfect picture of x, you look at something else. Now, this is going to see, we're going to see if you guys are able to apply this next part. This is where we kind of see if you guys can now do it on your own. Notice it switches spots now. I take f and I plug it in for g. So that's going to be the square root of x squared. That's different. That's different than what we just saw. Okay? And we know that the square root of x squared is x. So you still get the same thing in this scenario. But the domain is different. Talk to the person next to you, see if you can come up with the domain of that. Go, talk. What do you got for a domain?
You gotta do the bottom, then the top. So, x.
So here we started with the x squared. Now we got to start with the switch of x. What's the domain?
I think it's 0 to infinity.
0 to
That's
infinity.
just what.
So you're taking the square root of positives, right?
Yeah.
And then you're squaring positives, you're getting positive.
You go from here.
So
Because you have to
you
do the
will plug in a
bottom.
negative.
You gotta do the inside one, then the
Is
outside one.
domain.
You can't take the square root.
Did you get 0 to infinity?
Yes.
And the reason why is because you were starting with the square root of x. So the square root of x, you know that you can only plug in positives. So although you may say, hey, it's the graph of x, and you're thinking it's going to look like that, you can't plug in any negative values. So because you can't plug in any negative values, we can only plug in positive values. I bet when I graph it on my calculator, I only get that section. And sure enough, when you go into y equals, and instead of doing that function, if I do parentheses, the square root of x, and I choose to square that, look at what I get. I only get the right side. Okay? So, Let's put that thinking together for our last part. Flip to this. Part of your assignment today is going to be to find the composition of the functions and identify their domain. It says to determine f of g. F of g. So I'm going to take g, and where do I put it? Right on over here. So I get f of g is equal to 2 over 3 minus x. Now, if we think about it beforehand, the domain of 3 minus x is all real numbers. The domain of 2 over x is x cannot be 0. But neither of those tell me the domain for the composition. Rather, for the composition, 3 minus x, I can't have x be what number? Because then I would get 0 to plug in here, and that wouldn't work out. So the domain here is simply x cannot be 3. So you see, this is a little bit easier example than we started out with that square root of x squared and the other way around. But we can look at that and say that even though those are the domains for the original, it's not the domain for the new composition. And then for our last example for today, we take f and we plug it in right on over here for g. And we get g of f is the square root of 2x minus 6 minus 2. We can combine those together and get square root of 2x minus 8. Look at your domain ahead of time. The square root of x minus 2, we've done this plenty of times. You should recognize the domain is from 2 to infinity. And 2x minus 6 is just a line. The domain is all real numbers. But neither one of those tell us what the domain is of the new function. The new function, in fact, we have 2x minus 8 must be greater than or equal to 0 because we cannot take the square root of a negative. As we add the 8 and divide by the 2, we get x is greater than or equal to 4. So my domain is from 4 to infinity. Now, if I'm Zoe and I'm sitting here taking this test, do you like to get problems right or wrong? Good for you. She likes to get them right. So she's got some extra time on the test. She's going to go and check her answer. And she's curious because she noticed that this domain is 2 to infinity. This is 4 to infinity. Does everybody agree that 3 is not included in this one, but is in that one? So I'm just curious, what happens if I plug in 3? Okay, what happens if I plug in 3? Note it's g of f. So if I plug in 3 here, what's 2 times 3? Minus 6. Now I'm going to take 0 and plug it in here. 0 minus 2?
No.
Ooh, I can't do that, can I? So you can see that as you test values, you can see is your answer correct or not. Whereas if you try the number 5, 2 times 5 is 10, minus 6 is 4. Plug it in, 4 minus 2 is 2. Yeah, I can do that. So it's nice when you're able to check and verify. All right, take out your assignment. You guys have about 10 minutes. You're going to be able to probably get the front page done because you're super smart. You're the best of the best. It is in you that my hope rests to someday have Social Security. The front page should go pretty quick. It is just simply doing your normal composition. As you look at the back side, the back side is the graphing technique, which we talked about already. And then finally, at the bottom is involved. For each one, there's 4 problems. It's f of g, it's g of f, it's f of f, and it's g of g, and identifying their domains. Please do not rush through section number 3. Take some time and focus on that. I know Jacob has a great study hall. What hour do you have study hall, Jacob? Next hour. So he's going to use his 5th hour next couple days to really make sure that he understands section number 3, aren't you? Great hairdo today, by the way. Just a great option. You work the flow like nobody else, man. You really did. I know. It's just like I think of what kind of work I put in mine in the morning. So it just happens. I'm jealous.